remote corner of JFK Airport is Hangar 17. Home to this remaining 1% of the World Trade Center steel. After their collapse, the debris was removed from ground zero. Much of it was sold for scrap metal or disposed of in dump sites. But some key artifacts were culled and stored for future display. These artifacts suggest the immensity of the collapse.
It's very difficult to knock down something that's this massive. There's 1 million tons here that had to start accelerating and moving towards the ground. And what happened in this case is you had a whole floor where the fires were. That was 1 acre, and that steel was being softened by the heat of the fire. And as those beams bent and buckled in the heat, the whole floor started to collapse. And it may have collapsed just a little bit on one side and a little bit on the other. It may have taken a couple of seconds. But once it got some of its momentum, you had another 15 or 20 floors above it. Well, 15 or 20 floors is several 100,000 tons. Now you have a pile driver just pushing all the other floors down.
Purdue University worked with the American Society of Civil Engineers to create a science-based simulation to show the impact from the inside out. Purdue decided to model the first impact to show how the American Airlines 767 penetrated the North Tower. They began by modeling the World Trade Center complex, 7 buildings on a 16-acre plaza in Lower Manhattan. This would be a living model of the North Tower from the inside out. Purdue used original construction blueprints, photographs, and construction data to create a wire-frame World Trade Center structure. Every column, girder, and beam had to be in the correct place. They also created a scaled 767 jetliner, an aircraft with a weight of 141 tons, including 10,000 gallons of fuel. To model what this fuel load would do upon collision, Purdue launched fluid-filled aluminum cans to simulate an airplane wing impacting a steel column. A thermal camera captured the impact and fluid behavior. This raw data was also added into the sequence. Thousands of man-hours and 21 days of computer rendering were needed to show a total of 1 second of actual time. It took 2 years to complete the project. This is the final Purdue science-based simulation. The jetliner crashes into the 96th floor, severing a number of perimeter columns in the structure.
And you see, I can tell you quite honestly that we didn't fudge. The broken columns in the facade, by calculation, coincide almost exactly with those that were broken, so that our model was correct.
The simulation shows the impact from many different angles. Entry. Internal destruction of supporting columns. Disintegration of the jetliner. Atomizing of the 10,000 gallons of fuel. And the fires that attacked the steel network that supported the building.
You see, we're going to have a source of heat here that covers almost the entire core. And that starts heating the columns, which are unprotected. There is no insulation on them. And it starts heating the beams. See, the beams, in a manner of speaking, provide restraint at the edges of the columns, which are loaded axially in the vertical direction. So it takes fuel and oxygen coming in, of course, to add the fire. The temperature here could have reached beyond 1200 degrees Fahrenheit. And that doesn't melt the steel, it softens it. And that softening makes the restraints on the columns not as effective, and the column itself becomes soft. So it bends to one side, and of course there is a vertical load on it, and that takes care of it. So it goes away, and that's what happened in that building.
Purdue's findings confirm the report by the National Institute of Standards and Technology that widespread fires initiated by the jet fuel weakened the steel columns and brought down the towers.
Before 9/11 and since that one day, there have been 0 examples of high-rise steel frame buildings that have come down due to fires.
And truthers dismiss Purdue's forensic simulation as the result of inaccurate or falsified data manipulation.
It was like a controlled demolition, the distinctive kind of controlled demolition called implosion that makes the building come straight down. So you've got a massive amount of evidence that points towards implosion.
To address this controversy, we will conduct physical experiments to illuminate what really happened in the 9/11 attacks. 2,000 miles away from Hangar 17 in the New Mexico desert, jet fuel, 2,000-degree heat, and steel girders are about to be put to the test.
No steel frame high-rise building has ever come down in a total collapse because of any external damage or fire, even fire lasting 12, 15 or more hours.
Jet fuel is basically kerosene, which is a hydrocarbon. It doesn't burn any hotter than desks or chairs in the building. So it's not some massive fuel that can melt steel.
With engineering expertise and a remote desert location, we can test what burning jet fuel can do to steel. Emertech, the Energetic Materials Research and Testing Center, designs explosions to meet the criteria of this test.
At Emertech, we do tests and research in all kinds of energetic materials. So anything's explosive, pyrotechnic. If you light it off and it gives lots of heat and lots of noise, then we pretty much test it out here.
To show whether heat can really affect steel, an experiment will pit a 1-ton I-beam against 700 gallons of jet fuel.
So what we are trying to show is that if we took a weighted beam in a fuel flame and held it until it comes up to the temperature which weakens the steel, it will actually fail that beam.
Those are your chains, right?
In this test, a steel I-beam like those in the Twin Towers will be subjected to the heat from a jet fuel fire, the same flammable liquid spilled from the crashed airliners. Will the fire burn hot enough to deform the steel within the same window of time as the original structural failure?
And then we're going to just go get the beam, and it's 20 foot, so we'll just center it up on here.
On one of the testing pads, workers construct a fire pit, which will contain a reservoir of jet fuel. Though the World Trade Center had fireproofing on the beams, the National Institute of Standards and Technology reports that material had been knocked off at the moment of impact. And where the insulation was dislodged, the temperature of the steel rose rapidly. So in our test, a bare beam is used.
We're not doing an actual full-scale beam because to load a full-scale beam would take an immense load. And so